Hi all, this video is about 2D vectors. So like how we have two-dimensional arrays, we would be having two-dimensional vectors. And when we created 2D arrays, it was always like, for example, if I'm creating an array of integers, and let's say I want 4 rows, and for each row, I want 3 columns. That was generally how we went with. The first dimension is about number of rows in the array, and the second one is about number of columns. And we used to get something looking like this with 4 rows and 3 columns. Row 0, row 1, row 2, row 3, column 0, column 1, and column 2. This is pretty much how it used to be like a 2D array. In the same way, we can also have 2D vectors. And the beauty is that it's not necessarily this structure. A 2D vector um, can be something like this. Like we can have 0th row, 0 columns, 1 column, 2 columns. So there are 3 columns. And the second one, it could be having like 5 columns. So first row, third column, and fourth column. So the beauty of 2D vectors is that it's not necessary that all rows should have the same number of columns. And let's see in action on how we write the two-dimensional vectors. So hash include vector for working with vectors, and do not forget using namespace std. And let's do this. Like if I have to create a vector, so 2D vectors are nothing but, so 2D vectors, we also call them as vector containing vectors. So we have seen in the last video, we will start with vector keyword, and then we will have the angular brackets. Now, since we are creating vector of vectors, we have to give the vector keyword one more time. And now, after the second vector and int, this means these vectors, which are one-dimensional, are of digits, and I'm putting together a bunch of one-dimensional vectors. So, for example, this here is a one-dimensional vector. Okay, this part is a one-dimensional vector. This part is another one-dimensional vector. So, second one-dimensional vector. Like this, we can add one-dimensional after another one-dimensional vector, and to make it look like a grid kind of structure or a 2D structure. So this outer, this entire thing, if we wrap, visualize it as a box, and this box is a vector of vectors. So this box contains all vectors, one after the other. And if you take any particular row, for example, this one, this row is a vector of integers. Yeah, integers. So vector of vectors, vector of integers. Now, at the beginning, I'm creating an empty vector. So this means I have a vector of vectors and I'm calling it as V. There is nothing inside V. It's an empty box. So if I V dot size, it's go 0 because I created a 2D vector, but I haven't added anything. So this V is a 2D vector, and imagine a box. Now, the first thing we do pushback, pop back, and stuff like that. So let's add a vector to V. So remember, a V is a vector of vectors. I can add vectors to it. So for adding, we have something called as pushback. And remember, this V can take vectors of integers. So like in the previous demo, like how we added float values to a vector, this time we can keep on adding vectors to it. So I'm pushing back a vector, and this means it's an empty vector. Okay. So that means inside it a vector, I'm creating another vector, and this vector is for integers, and it's an empty vector. I'm not giving a name for it as well. I'm simply saying create me an empty vector. So this is how we are. So now let's see what the size of this vector is. Right. Now if you see inside this bigger box, I just created an empty box, and now this is at row 0. There is nothing in that. There is nothing in that. It's absolutely empty. But still, if we look at V, there is an empty vector inside the vector of vectors V. So because of that, size is an empty vector inside V. Now, we can also do something like this. If this entire box is V, to access this empty vector, all I have to do is like how we access in arrays, I can do V square brackets, and within that, I can give the index. So, see out, all I'm doing is the 0th vector, and which is, by the way, an empty vector. So I'm accessing the 0th vector, and I'm printing its size. Now, if you see, overall, in the vector of vectors or the bigger box, we have one empty vector. That's why size is 1. But if you see inside the smaller rectangle or this box right here, it's an empty one. So I'm accessing that box in V of 0. It's an empty one. So it's going to be 0. So far, I hope the picture is clear. Now, the task is add an element to 0. Remember, V of 0 is a vector, and it's a vector of integers. To access V of 0, doing brackets of 0 and push back, I'm adding 1. So this means the moment I do V of 0 dot push back 1, this means I'm asking the compiler to do this for me. So now 1 will be pushed. I go ahead and print the sizes. If you see this original vector V, it still contains one vector. So size is 1. And V of 0, whatever the first vector that we have here, this vector also contains one element. So size is 1. Now I can keep on adding V of 0. I can keep on adding more elements. I can add 2. I can add 3 and so on. And these elements, if I print these, if I print the size, you would see the size becoming 3 because we have now added 2 and 3. So that's why the size is 3 now. So as we add elements, the size will dynamically increase. Remember, of vector 0. Now, Now that I'm done with adding one element to the vector of vectors, I can also add another vector. I can also add another vector here, which is going to be empty vector. And this vector, how can I add? We can do something like this. V dot push back. So I'm accessing the main vector, which is V, not of one, the main vector V. And now I want to push back another empty vector of type integers. So this is how I would do. And now after adding this empty vector, if you see the size of this vector V, it's going to be it's going to print 2. So the size of the main vector is increased enough. So if you see, this is increased enough, and this part can be accessed with index 1 now. So this is, we can also see the size of individual elements. V of 0 means the first row, V of 0 size. And let me copy it and change it to 1. V of 1, V of 1. So if I run, you can see that the last vector that we add, overall vectors has 2 vectors. The first vector inside that has 3 elements, and the second vector has 0 elements. And now to add any elements to the second vector, I can simply do push back, and I can say 10. And if I print the size of it, it's going to say 1 now. All right. And if you see, this vector is having a size 2. Okay. And we can get that using v dot size. Now, to access the last vector, we can do v of 1 in this case, or v of v dot size minus 1. So size is 2. 2 minus 1 would be 1. In a way, it will translate to v of 1. So the same thing, I'll push back another element, v dot size minus 1, same as doing v of 1 dot push back 11. Push back 11. Now if I print the size of, it will say 2 because I just added more element. So v1 dot size is 2. And to remove this element, to remove this vector completely, whatever the vector that has 10 and 11, to remove this, what we can do is we can simply do v dot pop back. And this is removing an entire vector. So if you do v dot size, it's going to say 1 because we removed an entire vector now. This entire vector is gone now. It's only having 1 vector. And now, if I have to remove only 3 now, let's say if I want to remove only 3, so I can do is v of 0 dot pop back. And this would remove 3. And the size of this is going to be 2. So you can see the size is 2 now. So in this way, we can play around with vector of vectors, that too when the program is running, which means dynamically. And arrays, again, they don't support this. Vectors do support it. And that's all for this video. Try practicing assignment 1. And if you have any questions, do reach out to me. Thank you.